Okay, here's the third review video for exam 1, and I'm starting here just because I wanted to point out, wanted to emphasize that the video that is up on our website is, the first two are from a prior class a few semesters ago, and so things are slightly different. This is your question 4. It's question 6 of the second video. The only difference is that you have a +8 right here for the constant term, +8 here for the constant term, and that video the function in that video has a +5. The values in your solutions document obviously are correct, so just use those values. Everything that I say though in that video about the evaluation and the simplification and everything is the same. So question 6 is your question 4 from that video. Question 7 is your question 5, and question 8 is your question 9, and those two are exactly the same on your practice as they are in that video. Now, this video will start with the questions that are not on any existing video, questions 6, 7, and I believe 8. Let me see, 6, 7, yes, 6, 7, 8, and 10. I don't know that I'll make it through all those in one video, but I gotta start someplace, so I'm starting here where we left off, or where the other videos leave off. So in questions 6, 7, and 8, I have defined f of x to be x cubed minus 2x squared plus 4x minus 8, and g of x to be negative x cubed minus x squared minus x plus 8, and capital H of x to be the difference between f of x and g of x. So you subtract g of x from f of x. Subtractions are called difference. And question 6 asks you to calculate the derivatives f prime of x and g prime of x, and then use those to determine h prime of x. Now this uses the fact that if h of x is the difference between two functions, then h prime is just the difference of those derivatives. Now this specifically asks that you calculate these derivatives first before you use that property. And so we just use the power rule. It's very simple. You bring the 3 around front here and subtract 1 from the 3, so that gives you 3x squared for that first term in the f prime. And then again, power rule. Using the power rule, we multiply 2 around front here. 2 times 2 is 4. The negative stays. 2 minus 1 is 1, and so this is x to the first, which we don't need to write. So this negative 2x squared term then, when differentiated, becomes negative 4x. And then for the linear term, that is the x term, we just carry down the coefficient, which is positive 4. And the constant term, regardless of what it is, just differentiates out and it becomes 0. So the derivative for f of x, f prime of x, that is, the derivative for f of x, which is f prime of x, is 3x squared minus 4x plus 4. Now we have a similar circumstance for g of x, but there is a negative in the leading term, and so it's the same 3x squared except with a negative that we had when we differentiated this x cubed. And then the 2 comes, using the power rule, the 2 comes around front here, and this becomes negative 2x, and this becomes 1. and so that's negative 2x is that term, and the coefficient here is it's a negative 1. It's an invisible negative 1, right? And so that coefficient comes down, and the constant term differentiates out. It's 0. So h prime of x, capital H prime of x, is the difference between these two. So here's the first derivative right here. Then we subtract the second derivative, and this is where mistakes are often made. Remember that you're subtracting the entire derivative function, all three terms. And so a simple way of looking at that is that you just change the sign of each of these and add. So a negative of a negative is a positive, a negative of a negative is a positive, and a negative of a negative is a positive. And then in this step, which you don't necessarily have to do, but I only included for clarity, I collected like terms, that is to say the 3x squared and the 3x squared here are together, and the negative 4x and the positive 2x are here together, and the positive 4 and the positive 1. So 3x squared plus 3x squared is 6x squared, negative 4x and positive 2x is negative 2x, and 4 plus 1 is 5. So your final answer for capital H prime of x is 6x squared minus 2x plus 5. Okay, I had to interrupt the other video to correct a typo here. This did say 4x, which of course was incorrect. The 4x was factored so that it's 2 times 2x, but I'll get to that in a second. So 7 and 8 ask us to multiply a function times a factor and differentiate that product. Now you can do that in one of two ways. In the first shown here, I've pulled that factor out. I factored that multiple out, and then differentiated the function, and then multiplied a half times that derivative. So we saw before that the derivative of f of x, and let's take another look at f of x, 3x squared minus 4x plus 4, x cubed minus 2x squared plus 4x minus 8. And we saw before that the derivative was 3x squared minus 4x plus 4. So there's the derivative, and I multiply a half times that derivative, and a half times 3 is 3 halves, a half times negative 4, and a half times positive 4 are shown here with the numerator factored. Of course, the coefficient here does go to the numerator. This is the same thing as negative 4 over 1. And so here it's factored, and the 2's are canceled out, or one pair of 2's is canceled out. So the second term becomes negative 2x, and the third term becomes positive 2x. The other way we can calculate this derivative is to multiply 1/2 times the function first, which will give us 1/2 x cubed minus x squared plus 2x minus 4, and that is shown here, that multiplication with this step where I have factored the numerator, that's shown here, and then we differentiate the function using the power rule. Multiplying 3 times the 1/2 gives us 3 halves, subtracting 1 from the 3, that gives us a 2, so it's x squared, and then multiply the 2 times the front here, negative 2x, and the coefficient of the linear term then is the derivative of that term, and the constant term factors or differentiates away, it becomes 0. And the derivative of negative 2 times g of x uses the same, either of the same either of the same approaches. So here I factored the negative 2 out, and then I put the derivative for g of x, which was g prime of x, which was negative 3x squared minus 2x minus 1. And when you multiply the negative 2 times that, it just doubles all these coefficients and changes the sign. So negative 3x squared times negative 2 becomes positive 6. So it's positive 6x squared. Negative 2 times negative 2 is positive 4, so that's positive 4x. And negative 2 times negative 1 is positive 2. So that is the derivative of negative 2 times g of x. Or, as I said before, you can multiply the negative 2 times the function first. Negative 2 times negative 8 is positive 16. But all of these are doubled with their signs changed. And then negative 2 times g prime then becomes negative 6x squared, because you use power rule again. 3 times negative 2 is negative 6. And 2 times negative 2 is negative 4. And the coefficient of the linear term carries through, and the constant term differentiates to 0.